Hello and welcome to my channel again. I am Professor Dr.Mchem from Dr.Mchem Institute of Chemistry, University of St. John Sharp. Today I'm here not for any lecture series or something like related to your studies or something, to your previous lectures. I am today now very much excited because I got something, that is, I got my package. So what could be this package, right? It looks like a beautiful, you can see, packed box, right? It has nothing over it when I received it through, the post. So I would love to share my happiness with you people, because I've been waiting for this product, which I've ordered I think almost 15 days back. I got it now, I just received it now, so I thought I must share the unboxing of my molecular kit. Okay, so this is the actual molecular kit. It looks just pretty good, you can see here, right? It is a perfect box, so let's open. Oh wow! It has a small pamphlet, or you can say a paper, that tells us something about different atoms that are inside it, that are supposed to be inside it, right? With different colors and with the bonds, the shorter ones, the longer ones, and of course the flexible ones. So this is the beautiful molecular kit which I just received, and I'm very happy to have it because it looks the same what I have ordered. So that's really great. So let's see different atoms here. So these are different colored atoms. I suppose the green ones are for the chlorines. If I now look into this piece of paper which they have given us along with this, yes, this is the green ones are chlorine atoms, and yes, the purple ones, there are two type of purples, two shades. The lighter shades are for phosphorus, and there's a darker shade that is for iodine, okay, which is inside this one. The darker ones are for iodines, the iodine stuff. And okay, so here I go with different atoms. Okay, now here, this is something very interesting which I wanted to share. These are the, you can say, different type of bonds, right? And the connectivities. There are two types or three types of bonds. A shorter ones, that is the rigid ones, okay, and the flexible ones, the longer ones, that are for the, that are used, I think, for the for double bondings, unsaturation type of compounds. So this is it, right? And there are also some sort of connectivities also in between them, some sort of short and long bonds. Both type are there. Now here comes very interesting package, the other one. It is all, the white, these are all, according to my paper, the white atoms are all hydrogens. So these are all hydrogens. They are just beautiful. You can have a look at them. They are just lovely. And probably you see the hydrogen almost have a one connectivity, so it has a one hole in it, whereas the red ones are the oxygen atoms. According to our paper, yes, the red ones are the oxygen atoms, and the white ones are the hydrogens. So this is a nice package again. Well, and if we look into this fourth category, it is our, the black ones, they are the carbons. And as you know, that carbons have the valency 4, so it has the possibility of connecting to 4 different bonds. So one atom, it has 4 holes in it, so that we can join the different bonds and we can show the connectivities like this. These are the carbon ones. Okay, now so let's start preparing a molecular model so that you will have an idea of how you can prepare your own three-dimensional structure of any compound you like. So according to our paper, the first example they have given us is a methane molecule, right? This one. So let's start preparing methane molecules. For that, we need to have, first of all, we need to have a carbon atom, right? That is here, a carbon atom, right? Surrounded by its 4 hydrogens. So let's start connecting the hydrogens. Okay, one. They're pretty easy to plug in. So I think the quality has been improved, because the ones I've been using when I used to study, I had the privilege to get the molecular models. They were not that much, they were not that soft or flexible. They were a little, they were difficult to handle. So these ones are quite easy. See how easily it got itself connected. Wow. It's such a fun. It's just amazing how you can prepare a methane molecule, right? Carbon atom surrounded by the 4 hydrogens. Okay, so this is our first molecular model. See how beautiful it looks like. Okay, so does it resemble the structure they have given us? Yes, of course. There it is. You can see here. Match the structure, and yes. So according to our next compound, we have ethane. So let's prepare ethane. For that, we know ethane has two carbon atoms. So let's connect the 2 carbon atoms together. This is how you can connect the 2 carbon atoms. And now of course the hydrogens. This is really so enjoyable. If you know the structure of your compound, you can easily make it. Well, C2H6. So now we need to put the carbons to connect the hydrogens. Okay, 1, 2, 3. 4, 5, and 6. There we go. This is the structure of our compound, that is ethane, CH3, CH3. You can match it. So this is your compound, CH3. See how easily you can see the connectivities, and how easily you can see how they are connected to each other. The covalent bonding is easily shown between these atoms, right? So this is it. Now you can rotate the molecule easily because it is bonded by a single bond. So rotations are easy. See how they can easily rotate in the space. So this is it. So now we have our 2 models, that is methane and ethane. Oh wow, that's pretty nice, and I'm very happy that I've prepared these 2 models for you. I hope you like it. And because it's really fun when you know the structure of the compound. You can easily make them. You can easily make you have number of atoms here. You just select the atoms and you just start connect. So I'm back. Okay, so these were the 3 molecules which I've just prepared: ethene, ethane, ethene, ethane, and of course our first model, that is methane. Now you can see the different, how you can use this. The main purpose today is how to unbox this molecular model kit, and to let you know how you are going to connect the different atoms that are inside it. They have different sizes also, and they have different colors, and the colors are mostly you can easily memorize them when you just once or twice you will read them. And I would like to clarify one thing, that I've not been sponsored by any of these company. I'm just making my students learn how to use the molecular models, right? And they are easily available in the store, so you can go and you can get them. Okay, so now I was about to make the next compound I'm going to make is ethyl alcohol, ethanol. Okay, C2H5OH. Okay, so how you're going to, for that you'll be needing to, of course, carbon atoms, and you'll connect them with a short bond, that is not that long ones, not the flexible one. We just need a simple connectivity between them, right? So here they go, CH2. Okay, now let's connect the hydrogens. At one side it has 3 hydrogens, as you can see. And the rest. Okay, and here you have one. So sorry, not this one, the shorter ones. And here the most interesting part is you are going to use this red atom. What is this? This is an oxygen atom. So we are going to use this oxygen atom. How we are going to connect it? Like this. Wow. Simply looks amazing. And now there it is. C2. How many hydrogens? H5. 1, 2, 3, 4, 5. OH. Okay, now I'm going to attach the hydrogens to make the ethanol molecule, the ethyl alcohol. Okay, the most important solvent in organic chemistry we use for, recrystallizations, for preparation of Schiff bases, and many, preparations in organic synthesis, and for many other, in organic synthesis, synthetic processes. You need this compound called ethyl alcohol. So this is the 3-dimensional structure of ethyl alcohol I am preparing right now for all my lovely viewers. There it goes. Oh wow, just see how when you see it in the 3-dimensional structures, the animations on YouTube, you will simply see them rotating like this, sometimes like this. Okay, they will rotate and rotate. They are constantly rotating, and these bonds, they are actually not the bonds in between them, right? So, well, this is, I think I have prepared. This is your third molecule, CH3, CH2 according to this, and OH. So this is our third molecule, that is ethyl alcohol, this one. You can see it like this, okay? H5OH, C2H5OH. I hope everyone can see it. I will move it like this so that you can see C2H5OH. See, it matches. So there it goes, the third one. So today I have made you learn the... Okay, now, so I was showing you the ethane and the methane molecule. Just look at the ethane structure. The 2 carbon atoms and of course the 6 hydrogens that are attached to it. And you can easily rotate them. The most enjoyable thing is that you can simply rotate these molecules. You see how they are rotating. These 2 atoms that are having the hydrogens connected to each other. So they can be easily be, you can see all the conformations, right? Remember what are conformations? So we will discuss the conformation of ethane with the help of this molecular model. Hopefully I have planned that. So I have prepared these 2 models now. These are lying here in front of you. Let's now prepare the third one. Okay, that would be now, okay, yes, the ethane molecule, it resembles this one. This is your ethane. Yeah, this is ethane. So see, same ethane structure. Well, let's prepare, I think, ethane. That would be fun also. Or yes, let's prepare ethane. So for that we'll be needing two carbons, again the two carbon atoms, of course, and now I'm going to attach them together first with these flexible bonds. These are a bit flexible, you can see they are flexible, right? So first I will connect them like this, because I want to show you the double bonding, right? The double bondings will be a little bit curved bonding, right? So this would be like this. Just see how beautiful it looks. This is a double bond between the two carbon atoms. Okay, let's attach the hydrogens. It's so interesting. I mean, one can easily follow how these bondings are. I mean, in your imagination, it's not, imagination is very powerful, but sometimes you do need to see the things visually. You need to visualize things. So I think this is the perfect way how nicely now you can follow how the connectivities are there, how the bonds are connected. So see, this is a carbon with two hydrogens, carbon on the other side, two hydrogens with a double bond. So this is a ethene molecule. You can simply see here CH2 double bond CH2. Looks just pretty amazing. Is there any ethene inside here in this catalog? No, they have not shown us in the catalog. No, yes, they have shown CH2 and CH2. This one, the second one. Yes, the second one is the CH2 and CH2. You can match it. It's just the perfect. Okay, this is the third molecule I have prepared for you people to see. Methane, ethane, and then of course ethane with a double bond, with the flexible bonds, right? Let's prepare something else now. Let's prepare ethyl alcohol. Okay, for that again you will be needing two carbon atoms, C2H5. Everyone knows what is ethyl alcohol. The chemists, they all know what is it. So now I'm back to them again. So today I've shown you the different, four compounds which I prepared by using this molecular orbital kit I have prepared with the help of these atoms, right? And these bonds. I've prepared methane molecule, and then of course the ethane, of course, right? The ethane molecule, methane, ethane, you can see them, right? And then I prepared ethene. That is, I wanted to show you the double bond. Now see, the rotation around the double bond is difficult. It's difficult to rotate them. There is a barrier to rotation. We will study all these things afterwards. Today I just wanted to show you how these connectivities are seen and how they are made, right? And last but not the least, I have prepared ethyl alcohol, C2H5OH. This is oxygen, the red one. It's a beautiful molecule, you can see, right? So this is today's little review about this molecular kit and molecular orbital kit and the bonds that are inside it. I hope you like this video today and you will enjoy and you will you have learned how to use these atoms to make different compounds, right? The 4 compounds I have shown you, and I have shown you how to connect them easily. So you can use these molecular models if you wish to, or you can ask me. I am hopefully in my next few lectures I will start with you people conformational analysis of different compounds, right? And of course then we will move towards our goal, that is the stereochemistry, right? So I hope you enjoy my lecture today. You will learn, you will enjoy these structures, you will visualize them, you will compare them with in the book with their structure, just draw them, and then of course try to visualize them, that how see the connectivities. Now I have not mentioned anything about the angles that they are forming, or the bond lengths between them. This we will discuss. I've discussed in my few of the previous lectures, but I will repeat them. Today my goal was to show you how to make these models, and I am quite successful in making these 4 models for you people. So that was all today for today. I hope you will like this. So let's get pack them again back, and I hope you will learn from it. You have enjoyed this, something different apart from your studies, and you will enjoy. You have enjoyed this video, so please do share with your friends, and do try to memorize how the connectivities are there, because when you visualize through the molecular models, your concepts are all clear, right? So this is just amazing. You are lucky you have such beautiful models. At our times these models were not available, right? They were there, but very few of them have the opportunity to study on these molecular models, and I have not studied from my teachers on these molecular models. I'm learning now from YouTube and I am guiding you people, so thanks to the technology. So that's it for today. Wish you again with something new, something interesting, and something more exciting. Take care of yourself and your loved ones. Bye bye.